Hi everyone, in this video we'll see about cyclo converter control for three-phase induction motor drive. Cyclo converter is a frequency converter. So one level of frequency which converts into another level of frequency. So here we are using a frequency, we are controlling the three-phase induction motor. That's a very simple technique. We can control the three-phase induction motor by using cyclo converter. So three-phase induction motors are operates on AC supply. AC supply will have the frequency. By using frequency, so we can control the speed. So you can, if you see the speed, synchronous speed formula, ns is equal to 120 f by p. The speed is directly proportional to frequency. So frequency increases, the speed will increase. Frequency decreases, the synchronous speed will decrease. So that is the technique here. Cyclo converter control we are using to three-phase induction motor drive for controlling purpose. So coming to the cyclo converter controller, cyclo converter controller allows a variable frequency and variable voltage supply to obtained from a fixed voltage and frequency AC supply. So here we will see the half wave cyclo converter in below figure, right? So next one, harmonic content increases with the frequency, making it necessary to limit the maximum output frequency to 40% of the source frequency. Thus the maximum speed is reached to 40% of synchronous speed at the main frequency. So here we can see the cyclo converter uh, control for induction motor drive. So here we are using the three phases. So each phase is having 6 thyristors. So by using the firing angle, so we can control the speed of the induction motor. So for full 4 quadrant operation is obtained by reversing the phase sequence of motor terminal voltage. Since the cyclo converter employs a large number of thyristors, it becomes economically acceptable only in large power drives. So these drives we are using for large power drives. It's not using for small rating of the drives, since it is a more economical, more complexity. So that's what this type of drives we are using for large power rating drives. Here we can see the output waveform of each phase of cyclo converter. So here we are using the we are taking fundamental component voltage wave and phase voltage wave. So with respect of time. So phase voltage will be smooth sinusoidal waveform. Fundamental component will have some harmonics. So this harmonic content we are reducing by using the thyristors. So next one, if you see the applications of cyclo converter, so these cyclo converters are using in high power drives, so requiring good dynamic response but only low speed operations. Example in ball mills and cement plants. So cement plants and ball mills, so we are using the high power drives at low speed. So these cyclo converters we are employing in those applications. Next one, the low speed operation is obtained by feeding a motor with large pole number of cyclo converter operation at low frequencies, right? So we can also called these type of drives conventional drives, right? So because of gearless we are using, so without gears we are operating, so we and also we are eliminating the cost, high cost, and less maintenance and less space by reducing the number of gears in cycloconverter control drives, right? So next um, video will see about closed loop speed control and converter rating for VSI and cycloconverter induction motor drives, right? So this is about cycloconverter control. Here very simple, maybe they will ask in examinations. This is a wave cycloconverter diagram, and we have to explain the applications of cyclic converter. So next video will see this topic. Okay. Thank you everyone.